Assalamualaikum warahmatullahi wabarakatuh. Welcome to this video. Today I, Saulia Wanaf, will be one of your personalities along with my friends. Well, can I guess who they are? Today we would like to discuss about a certain topic regarding sound wave. Speaking about sound wave, wave is a disturbance in the air. In the medium that carries energy without a net movement of particles. Now, sound is a wave. It is a vibration that travels through the air or other medium and can be heard when it reaches our ear. Maybe you've seen this blue-haired girl before, or cyan-haired girl, or like this coat over here. Because the fans are going to detect me by skin color. Maybe you've seen her on YouTube, or you're obsessed with friend's phone, or some other places. So I will entertain your curiosity today, lucky rascal. Vocaloid is a singing voice synthesizer software, or to be put simply, a piece of software that enables users to synthesize singing by typing in lyrics and melodies. I'm sure you're curious on how she sounds like when she actually or not actually sings. So here we go. Oh my god, that's miku!
Alright, that's enough fangirling. So, after hearing Miku sing, or not sing, you will absolutely notice that there is something inherently different about her voice. You might think that it's just a very out-of-tune singing of a girl, but you're wrong.
So in a Vocaloid, a voice synthesizing software for producing music is used so users can input syllables and adjust the pitch to make the program sing, meaning anyone, even you lazy potatoes, can compose a song using the software. Much different than how a human would sing. When we sing, air is pumped by the lungs and directed through the vocal folds, which then vibrate, producing sounds that can be filtered and articulated by the parts of the vocal tract above those folds. These parts of the vocal tract, called articulators, include things like the tongue, the cheeks, and the lips, and in combination with the muscles around the vocal folds, they are capable of producing many different timbres and pitches. This is because the vocal tract is very dynamic, and its ability to constantly change while sound is being produced allows for very complex sounds such as sentences.
There is actually more than one way to store or record sounds. No, your heart is not one of those medias. Today I will explain more about digital recording since it's more relevant to our topic of discussion.
In digital recordings, microphones will be present. These microphones contain a diaphragm, which does a similar job to an eardrum. The vibrations in air make the diaphragm vibrate, and these vibrations are changed into a series of pulses that correspond to patterns of binary digits. Once we have a string of binary numbers stored, we just play back the digital recorded wave that we fed to the list of numbers to a device that produces a voltage equal to the number it reads. The changing voltages are amplified and fed to a speaker to reproduce the sound. This is called digital to analog conversion. If only it can also convert my delusions to reality.
Simplified, sounds are basically vibrations in the air. The diaphragms in microphone will vibrate because of it and change these vibrations into a series of binary digits. Those binary digits will then be stored and can be played back in a digital to analog conversion if we want to hear it again. That's how digital recording works. I think that's all I can contribute to today's discussion. Back to you, Tan.
Hi. Basically, a Vocaloid is a voice bank that contains the sound of the phonemes and a language. The phonemes will then go through a tuning process so they can become their intended products, being songs. Tuning itself is the process of manipulating the pitch and timbre of one speak to show which phoneme. Glasses.
Why do you need glasses anyway?
Psychology research explained that 4-eye tend to have more IQ count than 2-eye.
Is that true?
No, but there's possibility it might work.
Okay.
Thoughts?
Yeah, it works.
Shut up. We know that the pitch of a sound is determined by the magnitude of the frequency of a wave, and the musical scale is an organized fraction of the frequencies of each note. Therefore, all we need to do to change the pitch of a phoneme to the way we want is to multiply the frequency of the wave by a fraction. However, a voice bank's sound waves are more chaotic than pure tone waves, as every phoneme has different timbre, which makes it difficult to multiply the wave equation by a fraction without changing anything other than frequency alone. This is why we are introduced to the Fourier transform. Do note that I am no college teacher that invests much time studying physics, but rather do some minor that you can find anywhere, so I make a mistake or two. Fourier transform is also an incredibly complicated subject, so I will explain the oversimplified version because there is literally no reason for a normal human being to study it, except if you are not normal, like a miku fan. So basically, a wave that looks chaotic is actually a combination of several different pure tone waves or sinusoidal waves. Fourier transform is a method to break down a chaotic wave into many pure tone waves and present it in a frequency domain. The pure tone wave that has the lowest frequency is called the fundamental frequency and is the wave that has the greatest influence on the wave equation being deconstructed. The fundamental frequency is the wave that will be multiplied by a fraction so that the frequency change, thus getting the desired pitch. After this process is complete, the pure tones wave will be summed back to the time domain through inverse Fourier transform and can be read by a computer and translated into sound. You may think that summing an infinite amount of sinusoidal waves might take too much time, not to mention you need to deal with all the complex numbers and calculus, and you probably wouldn't want that. For that reason, a grandpa named John Tukey in 1800 created an algorithm called fast Fourier transform that analyzed the pattern of summing the waves, hence making it faster to be transformed. But if the voice bank only goes through the tuning process, we'll feel a pause between one syllable and another. Therefore, Kenmochi Hideki undertook a study in 2001 on excitation plus resonance, a device that creates sound from sound. EPR produces a method called pitch bend, a music effect on which one note will slide to another note, making the sound of the voice bank exponentially more natural. As much as I want to talk about math, I have not enough brain cells to actually do that, remembering I'm just some minor that has some mild hatsune miku addiction. For that reason, let me sing you one song now.